All right, so this is really just an example for Unit 6 problem solving that lets you see how differential equations could be used in a free response question or has been used in a free response question, and how it actually could incorporate topics from throughout this course, not just things we've done in Unit 6. So this is actually a 4-part question, so let's go ahead and begin. So during a chemical reaction, the function y equals f of t models the amount of a substance present in grams at time t seconds. At the start of the reaction, meaning time t equals 0, there are 10 grams of the substance present. So in other words, they're telling you right there that f of 0 equals 10. That's what they're telling you right there. It says the function y equals f of t satisfies the differential equation dy dt equals negative 0.02 y squared. So that's your differential equation that y equals f of t is actually the solution to. So part A says to use the line tangent to the graph of y equals f of t at t equals 0 to approximate the amount of the substance remaining at time t equals 2. So in other words, we're trying to approximate f of 2 using our tangent line approximation. Now, this is something that we did way back in Unit 3, hopefully you recall. And remember, if you're writing the equation of a tangent line, really the equation of any line, we're using y minus y1 equals m times x minus x1, where m is your slope, and then x1, y1 is a point on the graph. But remember, if it's a tangent line specifically, then your slope is the derivative. Okay, so they're asking us to use the tangent line at this point 0, 10. Remember, that was the point they actually gave us. So we actually know that this is at 0, 10. 0 is the t, 10 is the y. So if I'm trying to write the equation of the tangent line, I need to know the slope. But remember, the slope is the value of the derivative evaluated at 0, 10. Now, our derivative was negative 0.02 times y squared, but our y value here is 10. Now, 10 squared is going to be 100, and then 100 times negative 0.02 is negative 2. So this right here is the slope that we're going to substitute into that equation. And then remember the point, our x1, y1, that's our 0, 10, although it's a t and a y, not an x and a y. Okay, so that means our equation will be y minus 10 equals negative 2 times t minus 0. And if I solve this for y, I'm going to get y equals negative 2t plus 10. So this right here is the tangent line equation. And I'm supposed to use this to approximate f of 2. So that means f of 2 will be approximately equal to y of 2, which means that's going to be negative 2 times 2 plus 10. Negative 2 times 2 is negative 4 plus 10 gives us 6, which means that at time t equals 2, there will be approximately 6 grams. All right, that's part A. Part B says, using the given differential equation, and let me just write it down so we still have it for reference. Remember, dy dt equals negative 0.02 y squared. So using the given differential equation, determine whether the graph of f could resemble the following graph. Give a reason for your answer. So they're asking, this graph that they showed right here, could this possibly be the graph of the function that we're talking about, the function that is a solution of this differential equation? Now, remember that a differential equation is giving us the equation for the derivative in this case. dy dt is the derivative. And remember that the derivative is the rate of change of the quantity over time, or it's the slope of the graph. Now, if dy dt equals negative 0.02 times y squared, well, no matter what y is, we're going to square it, meaning y will never be anything less than, y squared will never be anything less than 0. So dy dt is going to be less than 0 because once you square the y, this is always going to be positive or 0, and you multiply that times the negative, and that's going to make it negative. So, and since y is never going to be 0 because it's the amount of the substance, so dy dt is going to be less than 0 for all y values greater than 0. So y equals f of t must, and before I write this, let's think about that. What do we know about the graph of the original function if its derivative is always negative? Think back to Unit 3. If we know that the derivative is negative, what is that telling you about the original function? It's telling you that the function must be decreasing. So y equals f of t must be decreasing. So now, keeping that in mind, let's look at that graph. Could this then be the graph of f of t? And hopefully you're thinking no, because right here, part of this function is now increasing. So this means the graph shown cannot be the graph of f because the graph shown increases on part of its interval. Sorry about that bell there, folks. All right, so again, this derivative is indicating that the derivative will always be negative because we're squaring the y, but then multiplying it by a negative number. So since the derivative is always going to be negative, that means our function should always be decreasing. But this graph right here is clearly increasing on one part of its interval, so therefore this graph cannot be the correct graph of f. Okay, now part C is going to be the one that's probably the most familiar to you, based on what we've been doing recently. It says find an expression for y equals f of t by solving the differential equation with the initial condition f of 0 equals 10. So this is exactly what you're used to doing, where we're going to try to solve this differential equation using separation of variables. So let's go ahead and go through this. So dy dt equals negative 0.02 y squared. So to separate, we're going to multiply both sides by a 1 over y squared and a dt. So I get 1 over y squared dy equals negative 0.02 dt. All right, so on the left side, again, this is actually a y to the negative second dy and a negative 0.02 dt. So now when I integrate both sides, we're going to get here a negative y to the negative first equals negative 0.02 t plus a constant c1. Now remember, this was with respect to t, and that's why it's a t. Now this is really negative 1 over y equals negative 0.02 t plus c1. So if I actually multiply both sides by a negative, that negative becomes positive, that negative becomes positive, and that sign's going to change, which is going to just give us a new constant that happens to be the opposite sign. So I'm now going to write this as 1 over y equals 0.02 t plus c2. All right, so now I'm going to go ahead and substitute my initial condition here. So again, now I'm going to use 0, 10. So we get 1/10 equals 0.02 times 0 plus c2. So c2 is 1/10. So that means I have 1 over y equals 0.02 t plus, now 1/10, remember, is really just 0.1, and since I already have a decimal here, I'm going to go ahead and write 1/10 as a decimal over here as well, just to be consistent. All right, so now there are two ways you can go about solving for y, because right now y is in the denominator. Of course, we don't want it down there. We need it to be in the numerator. So there are two approaches. We could cross multiply So we would multiply by the y and then divide by this whole expression. So that would then give me a y on one side, and then 1 over 0.02t plus 0.1. So you could do it that way. Another way to think about it is, if you have a over b equals c over d, then taking the reciprocal of both sides is still going to be true. So I could have done the same thing here. I could just take the reciprocal of both sides, and I would end up with the same result. Okay, so just something to think about. It might save you a little bit of time. All right, so this right here is our solution. So again, this is y equals 1 over 0.02t plus 0.1. Now, if you don't quite like that answer because of the decimals, you could do one more thing to simplify here. You could multiply the top and the bottom by 100. Now, why would you do that? First of all, 100 over 100 is really just a 1. So I'm just multiplying by a fancy 1, which doesn't change the value or the result. But I'm multiplying by 100 specifically because if I multiply 0.02 by 100, that's going to just make it a whole number. Same thing here. If I multiply 1/10 by 100, it's going to make it a whole number. So if I multiply the top and the bottom by 100, I'm now going to end up with y equals 100 over 2t plus 10, sorry. And then we could actually do one more thing here. We could factor out a 2 from the denominator. And then that 100 in the numerator and the 2 in the denominator could divide out, and we would finally get y equals 50 over t plus 5. Now, that seemed like a lot of work and potentially a spot to make a little mistake like you saw me almost make right here. So is there really any benefit to doing this? No, not really. It depends on what they're asking you to do here, but if they're just asking you to solve, there's really very little reason to go to here. You're generally fine stopping here. All right, last part. Determine whether the amount of the substance is changing at an increasing or decreasing rate. Explain your reasoning. Now, they're asking you to describe how the amount is changing. In other words, they're asking you to describe the rate of change of the rate of change. So in other words, the second derivative. Now remember, they gave you, to start with, the first derivative. So if I now want to find the derivative of that, then I'm taking the derivative with respect to t on both sides. All right, so the derivative of the derivative, that's going to give us the second derivative. Now the derivative of negative 0.02y squared with respect to t is going to be negative 0.04y times dy dt. But remember, we already know that dy dt is equal to negative 0.02y squared. So I can substitute. So I get negative 0.04y times negative 0.02y squared. And when I multiply those together, this is going to become a positive 0.0008 y to the third. Okay, now again, remember that what y represents here. Y represents the amount of the substance. And so we know that that substance amount is never going to be negative, and because we're talking about having an amount of the substance, they didn't really talk about whether it could ever equal 0, but let's go ahead and talk about when y is greater than 0. So if y is greater than 0, or let's just say since y is greater than 0, because we're talking about an amount of a substance, then that means the second derivative, well, if I put in any positive number for y and cube it, that will still be positive, times 0.0008 is still going to be positive. So since y is greater than 0, then that means the second derivative is also greater than 0. And that means if the second derivative is positive, remember what that's telling you about the first derivative. It's the same relationship between the first derivative and the original function. So since the second derivative is positive, then dy dt, the first derivative, is increasing. Again, because the second derivative is just the first derivative of the derivative. And the first derivative, being positive or negative, tells you whether it's one level above function is increasing or decreasing. And then finally, it's always good to make sure that you actually answer the question the way that they asked it. So remember, they said determine whether the amount of the substance is changing at an increasing or decreasing rate. So we can just say that the amount of the substance is changing, because remember, that's what dy dt really means here, is changing at an increasing rate. And there you have it. So this was an example of how differential equations can be and have been presented in free response questions before. And many times they don't even stick with the variables you're used to. Oftentimes it's with respect to time, because that's a very common application, is to talk about how something is changing over time. But many times they will not use y. They may use like a w or l or something like that. So some other letter, but it's just representing your y value, some other function. So try not to let that throw you off. Okay, good luck.